everyone. Thank you for joining me. Welcome back to another episode of the Ancient Health Podcast. My name is Courtney, and I'm so excited to dive into a fun little mini episode where we get to talk about nutrients. And I love nutrients. You should love nutrients too. And we're going to talk about the ones that come in capsule form that you're taking in the form of supplementation, which I think we could probably do a multiple series on because there's a lot of labeling that looks really great that make a lot of claims to improve your health, but what you're actually getting in the bottle might not be all that you think it is. And you might be making really expensive urine. So we want to make sure that you know what you're actually spending your hard-earned dollars on. And so today we're going to talk about folate versus folic acid. And if you're thinking pregnancy, you're on the right track because that's really what pretty much brings folic acid and folate to the forefront. Most people are thinking about that when it comes to pregnancy, but it is actually a really important nutrient for you. It's actually B9, so it is a form of a B vitamin, and it's found mostly in leafy greens. It's found in liver. So there's a lot of natural places where you're finding folate, but folic acid is a little bit different. And I want to be able to differentiate those for you because what you might be getting may be one, not hitting your nutritional needs, the demand that your body has for it, and then also might actually be causing a problem. So like I said, there's a lot of stuff out there that are on the shelves that, you know, they look really good. They promise to make you really healthy and feel your best, but that might not actually be the case. So folate, where does it originate from? Actually, this is a great way to think about it. If you think of the word folate and then think of the word foliage, that is actually where it comes from. And it makes sense because of the connection to plants and greens. So folate is what we're always looking for. That's the natural version that's found in the leafy green vegetables. It's found in the organ meats. Folic acid is a synthetic form. Now, it sounds synthetic, doesn't it? Folic acid sounds like something that was made in a lab. And you would be right. So there are genes in your body that produce enzymes that help you grab folate and use it. And so what we're going to talk about is how these two look different on a molecular chemical level and how they are used by the body, because this is a really important thing to know. Whether we're talking about folate, folic acid, or any other nutrient, your body has to use its genetics to create enzymes and use proteins to actually transport these nutrients to the cell receptor sites to actually get into your cell. So there is a really big series of events that have to happen to actually get the nutrients in your capsules or in your food into your cells to help your body. And that can a lot of times be a big miss. We just think, well, if we're taking the vitamins, then we're getting the nutrients. That's not necessarily the case. And I would actually recommend going back and listening to an episode we did with Kresser. This was a couple months ago, so I will link it in the show notes because I don't remember which episode number it is off the top of my head, but he is really good at understanding how nutrients affect your body and the prevention of disease. So I want to link that one in there. And he talks a little bit about nutrient bioavailability. And that's the point that can be a big miss because you can take tons of vitamins, but like I said, if it's not bioavailable to your cells, it becomes problematic. So let's talk about where folic acid even came from. So you're all familiar with the Industrial Revolution that took place when we took a lot of foods that were naturally grown on farms. We were doing things very homemade, you know, just on the homestead. And all of a sudden we started seeing these mega corporations and these big farms that are popping up that are monocropping, and they're doing things that aren't necessarily helping our bodies, but they're producing massive amounts of food. And in the process, they started stripping down nutrients because they realized, you know what, this stuff lasts a lot longer on the store shelves when we take a lot of the nutrients in it, because those start to go bad and then the products start to decompose and break down. But if you remove them, you strip them, guess what? Then you just isolate whatever it is, whether it's white flour, that stuff will sit there forever and it will never change. So all of this came about. And then after that time is when we started to see a rise in neural tube defects, spina bifida, infertility, to which all of a sudden it's, okay, we've got a problem. We're missing nutrients in our food. So we now need to be able to bring something in to enrich these foods. So instead of going back to the whole foods like we should have done, we now found that we can make synthetic nutrients and we can fortify the processed foods with these synthetic nutrients, forms of nutrients to satisfy the need. Well, did we really satisfy the need? Now, the quick answer is no, but we're going to break it down a little bit. So here comes folic acid. This is a form of folate that's added to cereals, grains, all kinds of processed and refined foods to address nutrient deficiencies. Now, there are genes in your body that produce enzymes that are going to help you grab folate and use it. Now, there is a different set of processes that need to happen to grab folic acid and use it. This is where the differentiation comes. So just to give a little background on genetics, and I won't go too deep into it, just a side note, I actually went to genetics camp in high school. This was like an actual thing. And we traveled up to New York City, and there's this whole thing. Watson and Crick, they're like the founders of the double helix, the human genome, all this stuff. So I went to a genetics camp. Shout out to my biotechnology teacher, Cherie Hagen. Still love you. And you know what? Here I am 20 years later, putting all of this genetics information that I learned into practice. So it's paying off. Thanks, mom and dad. Okay. So let's get back to genetics. You have 20,000 genes, and in these genes, they are responsible for creating enzymes. And this is really, really important because this is what actually helps convert the nutrients, the food, all the food that you eat. We're not just even talking about folic acid, into a bioavailable source of energy, and really to create ATP and to meet all of these different needs that your body has to keep you going. So if you've got what's called genetic SNPs, these are single nucleotide polymorphism. You will never need to remember that, but we call them genetic SNPs. The way I like to think about it is like they're kinks in the hose. Everybody has them. And everybody has them for different genes. And you get a set of genes from each parent. So you can be homozygous, meaning you have two variants. You can be heterozygous, meaning you have one variant, or you could just be wild, which means that you don't have any variants on that gene. But the vast majority of people have these genetic SNPs. And that means that you don't methylate as well, or that means that you have a limited capacity to convert something into a usable vitamin or mineral for your body. Now, you may be familiar with the MTHFR gene. This one really came to the forefront. It's probably the most studied. It's the most talked about by far when it comes to genes. And it is important because its job is to make methylfolate. So its job is to create an enzyme that actually converts a lot of these nutrients. So there's a particular gene called DHFR. And you may not be as familiar with this one, but whether you have a variant or not in the DHFR gene, you should not be taking folic acid. Now think about this. Folic acid is synthetic. It looks very similar to folate, but it is not. It requires an additional methyl group. So in order for it to make it through all the genes, because it's not just MTHFR, it's DHFR too. But if you get to DHFR and you've got a variant there, you've got some serious problems. And we're going to talk about that. And here's the other thing. If you don't have a variant, you still have problems. Okay, so let's get a little nerdy for a second. Your DHFR gene codes for the production of the enzyme dihydrofolate reductase, which then converts dihydrofolate into tetrahydrofolate, and then it converts into the active form of folate. So I'm saying all of this because you've got to understand there is a series of conversions that have to take place with this gene in order for folic acid to be usable to your body. So synthetic folic acid gets to the DHFR gene and it's transformed into dihydrofolate, but only by a little bit. And here's why. That enzyme, the DHFR enzyme, can only produce about 200 micrograms of dihydrofolate from synthetic folic acid at any given time. At that point, any more than 200 micrograms of folic acid, that enzyme says, nope, can't do it. That's all I've got. Now, this is really interesting. That's 200 micrograms. The RDA, the recommended amount of folic acid or folate is 400 micrograms. So if you're recommended to have 400 micrograms, but you can only really ever do at best case scenario, 200 micrograms, that's assuming there are no variants. If you do have a variant for this particular gene, then it's far less than that, like up to 40% less. And so that's going to create even more of a problem. So now you've got all this unused folic acid in your system and you think, okay, well, my body will use what it needs and discard the rest. Not so fast. So I love following Dr. Ben Lynch, and I'm going to link his book in here. It's called Dirty Genes. If you've never heard of him, give him a follow. We should probably have him on the podcast here soon because he does a really good job of breaking down genetics and helping people understand that your genes can be dirty, but they can also be clean. Your dirty genes can also affect your other genes. And we don't just mean the ones that have variants. Your genes and your genetics are influenced a lot of times by your environment. A lot of times we just think our genetics are what they are and we can't do anything about it. And that's not true. So I'll see if maybe we can get him on the podcast because he could go really deep into this. But I loved that he pointed this out. He said, if you're taking something and it's absolutely no use to your body and it's still getting in the way, then there is a problem here. And that's exactly what folic acid does. And how does it get in the way? Okay, so here's the thing. Folate transport proteins bind to these active folate receptors on your cells. So when you've got folate and you've got folic acid, then your body has to choose, and it's going to preferentially choose the folic acid over the folate. So how does this excess folic acid get in the way? So folate transport proteins bind it preferentially over the more reduced active folate. So they're kind of gunking up the receptors of your cells. So that can be a problem because now you've only got about 200 micrograms that you can actually convert and use. And then the rest is floating around kind of gunking up the receptors that your actual folate that maybe you are getting naturally from the meals that you're eating. And it can't get to the cell receptor sites because all this extra stuff's floating around, but it's not doing anything because it's not bioavailable. It's not active. So let's summarize this. To convert folic acid into methylated folate, there are a couple things that have to happen. You've got to have multiple genes that are now producing functional enzymes, which are also going to require adequate cofactors. And every person is different. So it's kind of crazy to me that we're recommending these high amounts of something that's synthetic, knowing that most people don't have the adequate components to make use of it. So what is recommended? This was surprising. I say that a lot, but I am surprised when I look some of this stuff up. So maybe you'll be surprised too. According to the U.S. Preventative Task Force, women of childbearing age have been recommended to consume 600 to 800 micrograms of folic acid a day. Okay, remember what I just said. You can only take in 200 to 220 at most micrograms. That is best case scenario. The recommended amount is they're saying now 600 to 800 micrograms. This makes no sense. Now, the CDC recommends that you start taking folic acid every day for at least 6 months before you become pregnant and every day while you're pregnant. They also recommend now that just women of childbearing age should just be taking folic acid. Just start taking it. If you are somewhere in your childbearing years, you should be taking folic acid. There are so many problems with this. This is why we are not proponents of these guidelines, because we now know that folic acid is not helpful for your body. In fact, it is proven that there are downsides to taking folic acid. This is why we're here, guys. We're going to do better because we know better. Okay. So what can we do about it? And this is the part that I want as a takeaway. If you don't remember any of the genetic stuff, or you're thinking this is so far over my head, what do I need to know? So when I go shopping and I'm buying a prenatal vitamin or I'm looking at a multivitamin, that I don't get the wrong thing. That's great. If you don't remember the other stuff, that's okay, because I'm going to give you the practical takeaways right now. So first things first, look at the labels. So choose something that has real folate in your dietary supplements. You do not want folic acid. So look for it on the back and you'll see it'll have all of the different nutrients listed. When you get to B9, it'll either say folic acid or folate. You always want to look for folate. And if it helps you to remember, think when I mentioned back earlier, it said, or I talked about how the word foliage, folate comes from that word, which means leafy greens. So foliage, folate. Folic acid seems very, I don't know, it seems like it belongs in a lab, right? Folate actually sounds like foliage. It sounds like something natural, which is what you want for your body. The other thing would be just make healthy decisions, incorporate a lot of good, healthy foods, and include those liver, those organ supplements. They are so nutrient dense. You would be so shocked at how much you actually get, because you also get all the cofactors with that too. And those also help increase the absorption. So avoid folic acid supplementation, avoid processed foods. Anytime you get those cereals or refined breads and grains and all of that stuff, they are going to add folic acid to it. So you may think, well, I'm not buying the supplements of folic acid, but if you're buying things off the shelf, those middle aisles where it's all the bars that are heavily processed and cereals, even like some pastas and things like that, they strip them down, but then they add in folic acid. So always look and check the back of anything that you're buying that has had some type of processing. Well, guys, I hope you loved this little episode. I know it was kind of a fast and furious little run through nutrients specific to folate and folic acid, but I hope that you now know the difference between the two and how to upgrade your supplementation specifically, and also the foods that you're eating. But especially if you're pregnant and you're a woman, make sure that you look for that in your prenatal. You will be very surprised to see. I actually went through the store the other day and I was really surprised that even at a health food store, there were still a number of supplements that had folic acid in their prenatal vitamins. And it even says it right on the front, made with DHA and folic acid. Like they were really celebrating it. And I thought, this is not good. This is not good. We need folate. We need the real good stuff. Personally, I took a lot of liver supplements and organ supplements as well. And we can do another episode on other pregnancy related nutrients, but I just find that sticking to whole food forms is awesome. Obviously a really good prenatal, but make sure you're checking the label, because even the brands that seem like they're doing all the right things and it looks really healthy, they might be skimping. And you know why they skimp? Because synthetic folic acid is cheap to make. It is so much cheaper. So they can actually hit the mark and feel like they can check the box, but it's not actually serving you in the best way for your health. So thank you guys for joining me. I love hanging out. I hope you are well. Have a wonderful day, and I will see you on the next episode.